So our last problem, kind of in this experimental section on enthalpy determination, reminds us about having kind of a new level to our mole game, and the concept of thermochemical equations. And so we have an equation here that tells us that the enthalpy is 1676 joules. So let me rewrite our equation here just so I can write some information underneath. Say Al2O3 solid makes aluminum solid plus oxygen gas, and delta H equals 1676 kilojoules. So one of the things that I want to point out in this concept of thermochemical equivalence when we have a thermochemical equation is right now this is written with units of kilojoules. It's not specifying per unit of something. When you see one like this, what this really means is that we have 1676 kilojoules of heat that will be, in this case, it's an endothermic reaction. So will need to be put in per 1 mole of Al2O3. And we can say 1676 kilojoules of heat for every 2 moles of aluminum. And 1676 kilojoules for every 3/2 moles of oxygen. So that's this concept of thermochemical equivalence. So again, we can see that this number relates to the coefficients in terms of moles of each of these species. And that's really important because that kind of gives us multiple unit conversions that we can use in this problem. Okay, so this problem tells us the major source of aluminum in the world is bauxite, Al2O3, and its thermal decomposition is how they generate elemental aluminum. So if aluminum were to be produced in this way, how many grams of aluminum can form when we have 1 × 10⁵ kilojoules of heat that's transferred? So again, this being a positive value tells us that this is an endothermic process. And an endothermic process means we treat heat as a reagent, as a reactant. So a reagent is just a material in our chemical equation. So endothermic reactions mean that heat as a reagent is a reactant. Okay. Once we realize that heat can be treated as a reactant or a product, depending on whether it's an endothermic or exothermic reaction, this just becomes a basic stoichiometry problem. The information that we're given is that we have 1 × 10⁵ kilojoules of heat. We want to be adding in 1,000 kilojoules of heat, and we want to know how many grams of aluminum that we can form. So again, information that we know, where do we want to go, and let's figure out the walk that we need to take to get there. Well, again, I might take a little bit of a walk backwards here. I can get 2 grams of aluminum if I know moles of aluminum. I can use, again, my balanced chemical equation to kind of walk between moles of aluminum and moles of aluminum oxide here, again, or bauxite. So one of the ways that we can do this is we can walk between these 2 species, or I can use one of these directly. What I'm going to do is I'm going to use this one directly. If I know moles of aluminum, I can use this guy directly to walk from here to here. So the heat to moles of aluminum, I can use delta H for that. Again, it would not be wrong if you went and used the chemical equation to go from moles of aluminum, and maybe I'll just kind of draw that as a dotted line here. You could go from moles of aluminum to moles of Al2O3, and then you could go here again using enthalpy, but we'd have to use this guy versus this one. All right, so let's just kind of walk through the solution of this problem. And again, the new piece of information is using delta H, which relates delta H, again, is equal to 1676 kilojoules for every 2 moles of aluminum. So again, if I'm taking the walk that I have in solid lines here, this is the delta H I need to use. If I wanted to take that extra little walk here, I would need to use this one. All right, so let's go ahead and walk from information we know. 1 × 10⁵ kilojoules of heat. 1676 kilojoules of heat mean that we've got 2 moles of aluminum. We could stop at this point if the problem asked how many moles of aluminum are formed, but they ask how many grams of aluminum are formed. So again, we need to use the molecular weight to convert that. 1 mole of aluminum is 26.98 grams of aluminum, and we would make 32.20 grams of aluminum by putting in this much heat into an excess amount of bauxite. So again, that's assuming that heat is going to be our limiting reagent. We're going to have an excess amount of this bauxite. So again, just one more way that we can walk to moles, right? 5 ways to walk to moles now. Number of items to moles via Avogadro's number, volume in liters to moles via molarity, mass in grams to moles via molar mass, information on pressure, volume, and temperature of a gas to moles by using the ideal gas law, and now heat of a reaction, kilojoules to moles via delta H.